UnityBot. My name is Samuel Roses, and
I'm Dan.
I'm Steven.
I'm Mike.
I'm Austin.
we're UnityBot. Okay, so our mission at the beginning was to create a robot that is under or about $25. But instead of doing that, we actually decided to develop a kit so that it could boost their engineering experience for our target audience, which is the middle schoolers, at a low cost, which will also benefit them by sparking their interest and creativity.
So when developing our product, I'm gonna come over here. At first, we were gonna do the $25 robot, and as Sam said, we moved more into building a kit for the kids to have more of an engineer's experience by working on all the aspects of building a robot, which is the electrical components, programming components, and the actual mechanical components, building the whole robot. And in our design process, throughout intensive research, we've been looking at many materials and how we can formulate a kit in which it'll be safe and easy to use for middle school students to be able to build this robot and use all the materials in order to work on all the 3 different fields that we are aiming towards. The build process, while we were researching materials, we were looking into what can cost less, but what will be easy to use so that it's interesting. Because if we use more like our prototype looks more like an arts and crafts project rather than building an actual robot. So maybe in the future, when we go into the build process, we're still researching on how to find better materials to make it more of an actual experience rather than children using, simple materials in order to build a small robot.
All right, so it's a pretty well-known fact that programming is not a very easy thing to do. And a lot of people don't like doing it, especially younger kids, like middle school age students. So I saw that data, like when I had kids doing the workshop, a lot of them just didn't seem interested, they didn't even try. They didn't know what to do, they were confused, and they didn't know why they need to do programming. But the truth is that programming is something you need to do in robotics, or else you pretty much have like just dead mechanical parts, right? You have like a toy car you move by yourself. So about 60% of our manual is actually designed around programming. It shows them step-by-step what to do, line by line of code, and it actually lets them experiment on their own. So rather than just saying, do this, type this in, and hit run, it's like, type this in, here's how this works, and now try to modify the code so that the robot will do something else you want to do. Or here's a challenge, see if you can modify code to do something else. So this way, they're interactive learning, and they're not just like being told what to do mindlessly.
All right, and for our electrical, this is really where the challenge of making a robot for $25 came into play, as almost all first proprietary electrical components cost $25 themselves, and we need many components to make a working robot to meet the best specifications. So what we ended up settling on was an Arduino Mini, which we bought for about $3.40, 2 DC motor controllers, a battery pack, a breadboard, along with various wires, one L298N motor controller, which can control both motors. And originally we were going to purchase 2 of these per kit, but we realized as we began to work with the code more and with the electrical system, that one motor controller can power both motors in independent states. And as such, we were able to reduce the cost of the electrical components from about $20, which was about 80% of the cost, to about $17.
Okay, so as my co-intern said, electrical components took 80% of the budget, which from $25 is a lot. So we only had about $5 to work with for the mechanical team. So we decided to use the material coroplast, which is a plastic, and it's like a cardboard but in a plastic. It's used for yard signs and such, and it's very cheap. it had the structural integrity that we were looking for. The coroplast is right there. Yep, that's it right there. And there's the kit as well. So this is the coroplast. We found this a 96 by 48 inch of this for $15, and then when we divided up into a kit, we came out with this size, and this size is about $1.80 per kit, which really reduced the cost of the material. As he said, we decided not to build the robot itself, but cut it into different shapes so that the kids could build, our target audience could build anything they want, really. So when we cut it into shapes, that made it final that per kid, the target audience would only spend $1.80, which was really helping us. Besides that, we also decided to use pipe cleaners as flexible connectors. So instead of screws, nuts, and bolts, which are very dangerous because our target audience could play with them and somebody could end up swallowing them, it could be really dangerous. So we decided to use something safer but fun-looking pipe cleaners. So flexible connections, they could. We decided to tie the end with tape, and then this goes into the hole that the coroplast already has, so it connects the pieces really well. And it doesn't have to be a rigid connection. But if the audience decides to use a rigid connection, we decided to use bamboo sticks. So all these connectors per kit also cost $1 because pipe cleaners are very cheap, so are bamboo sticks. So together that's about $1.50 per kit. So far we're at about $3. Besides that, the only extra thing that we used in the kit for mechanical is tape, Velcro tape, to have everything standing on the robot so it could be permanent connection. And we're contemplating on glue. As Steven said earlier, when we had a survey where we had target audiences come in and try on our materials and see how well they work with it. And we saw that this material looked like arts and craft. It looked like paper. It didn't look like something you could build a robot with. It actually is, but for our target audience, it just looked like arts and craft. So what we decided to do was something cost effective to do would be spray painting it metallic. If it is, when you think of robots, you think something metallic. If you color this into something metallic, that would already trick their minds into thinking, hey, a robot, So that's one thing we're thinking of. Besides that, that's all we needed to do for mechanical. So that came out to about $5, which stayed under the cost. So that's the cost analysis for the mechanical parts.
So now we'll just go one by one talking about our learning process throughout the 2 weeks that we've had here in the internship. And I'll open up for anyone who would like to go first.
So my learning process, I've in my school, because I don't go to ESUMs, I do manufacturing and as a trade. But I don't really have experience as an engineer, because all we really do in my shop is cut metal to certain diameters. We measure metal and we also lay out, do bench works. But I never really learned how to build a robot, seeing people put electrical components together. So I would say in my learning process, I learned how something so simple you can put together, and it can create something exciting and more interesting to a minor.
Since I go to ESUMS and I have an engineering background, sort of not that deep background, but a background, I've learned a little bit more about like what it costs to build a robot, how much it is, and how much like you could get anything to actually build a robot. Like this costs $25. It's not that much.
With me, I work with Vex Robotics, and one Vex kit is about $1,200. I've always wanted to build my own robot at home, but I'm only introduced to Vex Robotics, and that's the simplest robot you could basically build. And I was never able to do that because it's $1,200 per kit. And then I came here and tried to do what I wanted to do for myself or other people, which is build a lower costing robot. And I didn't think it was possible at first. There's Diddy, who just gives you challenges and you just have to find ways to overcome it. And that's exactly what we did with our team. And we found a way to make a moving, working robot under $25. And that was a really learning experience for me because, one, nothing is impossible. Two, it's really easy to use what's around you to build whatever you can imagine, and that's real engineering. So that's what I learned.
Being someone who used to build things as a child, and coming from ESUMs, I've done a lot of engineering work. Throughout this internship, I learned more of the development and production side of things when it comes to mass producing a product, and that was a brand new experience. I would like to see this product go further and be able to be a part of the future development and production of some type of engineering product. It's relevant and it's fun to me, and I enjoyed it.
So I have a lot of experience doing like desktop and command line programming, and a little bit of experience doing programming for robotics because I was on the team last year. But I have like no experience doing stuff with Arduinos. I've used something called Raspberry Pi, which is kind of similar, but it's a little bit of a different role. It's not really the same thing. So I don't have much experience with circuits, much knowledge of how it works, of electricity, or any of that. So building the circuit with George is pretty interesting. It took us a couple of days over schedule just because we ran into some problems and we killed a little bit of hardware. But now we know what not to do, and we can take that knowledge we've learned and put it into the manual so we can make sure people who buy this don't make the same mistakes we make.
Yeah, and probably the most important thing I've learned at this internship is planning, preparation, and knowing what you're going to say when you stand on stage, as well as eye contact with the audience. But like Austin said, we may have killed some hardware because when we bought a lot of the electrical components, well, I also learned the importance of cost comparison when buying products. There was a lot of that because we had to find the low-cost products that could also do the most for us because there were many different usage for anything that we wanted to buy. So knowing what you're buying, we learned is extremely important, and also knowing how to research what you're buying, where it's from, and like how it's different than the other products that are on the market, even though they're marketed as the same, as well as forums and such, and how the community that's created around what you're buying, how they can help you, and how you can learn from their experience, make it your own to make a better product.
So, looking into the future, what's good about this is, first, we got a very good kit, under $25, which that is perfect, you know. Kids, as we did the survey, kids, they really enjoyed it, putting the stuff together, seeing how stuff can be put together, using their imaginations, and they really made some nice pieces. But in the future, with the Coroplast plastic, as you can see, it's like when you look at this, it's plain, and you know, kids they get bored easily when you see like plain stuff. They get bored easily, as we all know. And we would like to add like not a new sheet of product. Coroplast plastic was perfect. I don't want to change the Coroplast plastic, but we would like to add like a metallic color to it to make it look cool, to make it add a design to it, so they can see that it's more than Coroplast plastic. That whatever they build or choose to build, it will be more fun to them as a personal experience. And also as a future into the future, we were talking about better machines and tools, because while we were cutting the Coroplast plastic, while we were cutting it, it was, as you can see, it was bumpy. You see, it's bumpy, and we wanted to take off the sharp edges because I poked a lot of my fingers while cutting it. But it's also a safety hazard, and that's something that's really big with products because anybody can get hurt with the pointy edges. So with better machines and better tools, we could cut it straight lines, make a good product, and also make a safe product, which is very important in the industry. Money-wise, into the future money-wise, as we did good with $25, raising it up to no more than 50, but 50 is perfect for us. So we would have a good product, but we want a great product for kids to, you know, really get the engineering experience. With $50, we could probably make so many kits for kids, and make the product and make it look interesting and make them want to do this again, want to do it every day, you know, want them to be an engineer when they grow up, see themselves in the future in the engineering business. Time-wise, we did good for 2 weeks. We did good. We got every kid. We did surveys and they loved it. What we did a lot of perfect things, but I would say adding like another week to it, we would have been done completely, and we would have had a robot running right now if we had extra time into the future. And also, we were talking about better quality of our tools. See, we used for this, we used, what's this tape?
Paper tape.
We used just paper tape, like regular tape. But as kids were using them, these tape, they wasn't as better quality as we wanted, so they were like ripping off easily, and that's something that we needed to work on. We needed to get better tape, and make sure that the kits they stay together when the kids build, so it has a long-lasting build to it. And then emphasizing the purpose. So this product in a whole is great for school kids. It's great for kids to get the engineering experience, for kids to realize that nothing like this is not just a computer. You have to you have to grab the body, you have to put the components together in order to make something as a computer. We want kids to see bigger, see the inside of things rather than see the whole thing as a whole. And for the cheap, and as doing that, we want them to see that, you know, we want, you know, basically to teach them that, yes, it's hard, but at the same time, it's, you know, it's a learning experience. They gives them the knowledge to continue life, because also seeing the deepest components inside building a computer or building a desk, a table, whatever, building anything, that it starts small and it gets bigger.
Really, really inspired by you guys and impressed. I think that the kinds of things that you're getting at today are exactly the types of things that we want to get out of this sort of program. Diddy and I were talking about this over the past several months. Diddy started talking about it with Bruce a long time ago. In terms of the purpose, you know, like you said, there's a real need to make a less expensive robotics kit. Students who are in schools that can't afford to pay for $1,200 kits, and even when you can afford, you can't necessarily afford to have lots of students learning about it. Only some. Even at the most wealthy schools, you can only have so much of this. So this is a vitally important project that you're working on, and I appreciate that you appreciate the purpose, because behind CPEP Ventures and these programs, really it's about what's the purpose and connecting your learning with real purpose, creating something that's going to add value for others. So it's incredibly purposeful, and I'm inspired by all of you and how you articulate the sorts of things that you're doing in this program are the sorts of things that adults take for granted. You know, comparing products, like you're in charge. You have to make choices about budgets, about costs, about purchasing. You have to make choices about making things safe for other people in a way you're accountable for others. And
applying the things that you've learned and having to learn new things, right? Like learning Arduino when you hadn't really worked on that before. On the job, all of us adults know that you don't always know the things that you need to know when it comes time. You need to figure that out. So I'm very inspired again, and look forward to continuing to support your work to build this out. This is not the end. It's the beginning. And I want to thank Didi, Didicus Abracha. Did I say it right?
Yeah, you got it right.
Close.
You got it right.
For the vision and for the facilitation and the expertise and the guidance. So thank you all. Big round of applause to you guys. We'll take the next steps to roll this out for piloting in the CPEP after school program.
All right.
You ready?
Okay.